All right, so this is going to be notes on 5.9 on mining, rather than doing notes in class or having an Edpuzzle on it. This link we will look at together. It's looking at specifically the amounts of different materials that we're mining, so that we have an idea of what kind of ores we're talking about in this context. Okay, so some vocabulary about mining that is important when we're talking about all of these methods. First is what you're mining for. An ore is that commercially desirable material, the thing that you want. But a lot of times it's not particularly easy to get to, it's not just sitting on the surface. The amount of ore that you can profitably mine and access, so not all of what's there, but what can be effectively and efficiently removed and harvested is the reserve. So if you're talking about the coal reserves, that is how much coal is left that can actually be accessed and make a profit. Do it without losing money in the process or losing energy. The stuff that's in your way is called overburden. So anything that's on top of the ores, anything that's blocking the access of the mining operation to the ore is called overburden. But in mining, when you remove that overburden, it becomes something else. So when it's on top of the ore, it's overburden. But once it's removed from whatever mining technique you're using, it is called spoils. So overburden, it's on top of it in its original conformation. You remove it with whatever technique you're using, it is now spoils that material. Some additional vocabulary. A lot of times the ore is not just pure and easy to retrieve just that thing. It's surrounded by other material that you don't actually want, but you can't remove it from the ore. So it's kind of interspersed, it's combined with the ore that you want. That's called gangue. Down at the bottom, there is an ore cassiterite that has tin in it. It is something that is commercially valuable, but it's mixed with a bunch of other material around it. That is the gangue, and specifically in this instance, the gangue is comprised of quartz crystals. To get the ore separated from the gangue, it has to be refined. That refining process is usually a combination of mechanical, like crushing and breaking it up, as well as chemical processes. For example, in gold refining, they use cyanide in the process of separating the gold from its gangue. In that process of refining, you end up with some waste that's left over. That waste has the gangue material, so the leftovers from that, as well as whatever chemicals that you are using in the process. We call that mix of unwanted waste that is left over after refining tailings. Tailings often are pretty toxic. Like I said, in the refining process for gold, the tailings would include cyanide. That would often be put into a tailings pond, and sometimes is leaked into water, similar to the lagoons that we saw, the manure lagoons with CAFOs. Tailings ponds are also highly toxic and have a lot of potential contamination risks from heavy metals, from sulfides, from acidic content, or from radioactive material, depending on what you're refining. These are some examples of tailings in actual circumstances. This is what they look like. Those bright colors are because of the chemical reactions that are happening within the water. Okay, so as far as how mining is done, we kind of break it up into surface and subsurface mining. It is exactly what it sounds like. Anything that is surface mining, you're not going underground. You may be removing material, you are removing material, but you're not actually tunneling into the ground and going below ground. Regardless of which technique is being used, you're going to have to get to that mining site. So step one is always going to be to build a road, build some sort of access point to the mining operation. That's going to fragment habitats, it's going to destroy habitats, which leads to a loss of biodiversity. A lot of times these mining locations are in fairly remote, relatively pristine environments, and so this is the first step in environmental degradation that happens, is the building of the road to actually get all of your machinery where it needs to go so that you can access the ores. If the ore that you're trying to get to is relatively close to the surface and is kind of running alongside or parallel to the Earth's surface, then you can use strip mining, which again is what it sounds like. You're removing big strips of soil, of that overburden, the soil and rock layer that is on top of the ore, and getting that ore out from that. Most of the time, they're going to put all of the overburden the spoils that come from the overburden. They're going to put it off to the side and then replace it afterwards in what's called mine reclamation. This is the kind of machinery we're talking about. It's not like a guy with a pickaxe doing like a folksy gold mining operation. These things are huge. There are, I don't know if you can see, but the bucket down at the bottom is man sized. A person can fit inside of that. So it's going to strip the material. These circular wheel components are buckets, so kind of like a big bulldozer, excuse me, that is scooping up parts of the soil and rotating it around back to a conveyor belt where it can go and be taken for refining. Here's a scale picture. These mining machines are massive. They're giant. Some of the operations are going to have things like that. Some will rely more on things like backhoes and bulldozers, and less on these gigantic machinery pieces. Open pit mining is very similar to strip mining, but you're leaving an open pit, and it's not just like a level surface. You are looking at an ore that is extending horizontally and down into the ground. It's not just one strip of material that you're accessing. A lot of times these pits are left open, they're left this way. They can be used for other things like becoming a landfill, but that does require some additional processing, some lining and waterproofing to make sure that the landfill waste doesn't leak into groundwater. Or they can become a pond or lake. If you just leave a big open pit, it's probably going to fill up with water. This is an example of a pit that has become just a lake. This is a quarry pit. It's actually in Georgia. This is where they filmed part of the first season of Stranger Things. So this is an example of what can happen after open pit mining is finished with their operations and leave that pit. Open pit mining is very dangerous. I don't know if you guys remember, but in about a year ago, in 2023, there was a massive collapse of a coal mine, of an open pit in China, and 53 people were killed in this accident. But when you have these super steep sides and you don't have appropriate support, at some point you're going to have a collapse. You're going to have a massive landslide. So this is one of the most dangerous forms of mining because of the potential risk of collapse. And that is a lot of material. It's a lot of rocks, a lot of material that collapsed. In addition to the actual danger of the pit mines in terms of their collapse, anytime you have this exposed ledge, an exposed vertical face like this, you're going to have erosion problems. We've exposed a lot of soil. You're going to lose soil in erosion from wind and water movement. You've also changed the albedo. If you had vegetation there, you removed it to make these mines, you have lowered the albedo. It's going to hold more heat. It's going to be a hotter area. And you have all of these problems of removing vegetation that we've talked about with urbanization and with habitat destruction. Okay. This is another one that is what it sounds like. A lot of these terms, besides the initial like overburden and spoils and tailings and all that, the actual methods are named for what you're doing. So mountaintop removal, this is something that's used a lot in coal mining, specifically in Appalachia. And they use explosives to blow up the top of a mountain to remove the actual top layer and sequentially remove that top. All of the material that is disrupted by that often is put into surrounding valleys, so you end up with this kind of leveling of your ecosystem. This is an extremely destructive form. You can't put a mountain back together. It just doesn't work. Even if you try to pile up that material, it's not compacted anymore. You're going to end up with this expansion of your material because the rock is not solid anymore. You've made it into a bunch of tiny little pieces. It's kind of mind-blowing how much change this has done to our landscape. If you go to Google Maps, which I did here, you can zoom in. This is West Virginia. All of those light colored areas are areas where mountaintop removal was done, where coal mining took place. And you can see this from satellite imagery. I didn't know where these mines were. This isn't something that I'm super familiar with in terms of West Virginia geography, but you don't have to be. You can see them from space. You can see those blonde spots, those really light colored spots, and those are mining operations. So this is something that will have massive habitat disruption that is going to leave a lower albedo, you're removing vegetation, you're going to have issues with your evapotranspiration in the water cycle. You're changing the way that the watershed is shaped if you're moving that material and filling in valleys. This is going to have massive impacts on water cycling in this area, as well as the distribution of organisms in their habitat. Oop, we don't need to watch it again. Okay, the last method of surface mining is placer mining. This is kind of what you would think of if you're thinking of like a gold miner going to a stream and getting some water and shaking a pan. Essentially, you're using density and gravity to help you with the separation of these small eroded pieces of material like minerals and metals and precious stones from river sediments. Rivers take stuff with them when they move. And so if there was a vein of an ore somewhere upstream, there is a possibility that you have some of those materials in the water itself, and you can separate them with this shaking and density-based method. However, we don't necessarily do it quite like that anymore. There are people who do it as hobbyists that still mine kind of like the old school gold miners, but it looks more like this with large machinery that is moving large amounts of water, is using technology to do this process more quickly. And we do end up with some pretty substantial degradation of the waterways from these more industrialized methods. A lot of disruption of the sediments, a lot of disruption of the water, and changes in flow. So all of those were surface mines, surface mining techniques. Sometimes the ore is too far below the surface to make that practical. You would have to remove a huge amount of material from the surface. And so instead, you can make a subsurface mine where they drill down to where that ore is and then mine it under the surface. Generally, this is done if the ore is more than 100 meters below Earth's surface, but the deepest ones on Earth can go up to 2.2 miles, which is wild. This is a very dangerous environment. A lot of times you have oxygen poor places. You have potential for releases of gases like hydrogen sulfide from below ground, like geologic activity, which is highly toxic. That's the kind of reason that you would see canary in a coal mine. They would bring those down because they're more sensitive to air quality issues. And if the bird is having trouble, then the people are definitely going to have some trouble too. But the bird was an early warning sign that there was some sort of air quality issue. A lot of times, the air quality issues were not just that there was potentially a toxic gas like hydrogen sulfide. There's also a lot of particulate matter that they're breathing in. If you are mining this material, if you are using explosives, if you are disrupting the rock and soil, you're going to have dust. You're going to have all kinds of particles that you're breathing in, which is when you would see things like the black lung with coal miners in old school subsurface mines. And I say old school, but it's still, if you are in a subsurface mining operation, there are substantial needs for personal protective equipment so that you're not breathing in all of this toxic material. You also are at risk of collapse if it's not engineered well, if it's not built well. You have a lot of material on top of you. If you're 2.2 miles underground, that's a lot of weight that needs to be supported in order to safely go into these tunnels. So a lot of risks associated with subsurface mining. All right, so this is kind of a summary table. You can pause here and look at the differences and similarities between surface and subsurface mining, but both of them are going to have impacts on air quality, on water quality. They're going to have impacts on the soil, biodiversity, and human health. So you can pause that, look at those differences in impacts of surface and subsurface mining. Theoretically, in most mining operations, there is a requirement of reclamation. Reclamation is when they put it back. You put the overburden back to where you got it, you restore the habitat to what it looked like before, or something suitable and alternative. So like if you're doing a mountaintop removal, you put the overburden back, you put the spoils that were overburdened back onto where you found them and plant some sort of vegetation, ideally to hold them in place. Realistically, you are not going to get it back to what it looked like. Millions of years led to that particular setup of the land, and you're not going to be able to do that with just machinery. And so it's kind of like a duct tape fix of, yeah, I fixed it. See, it looks better. It's not really all that possible to make it pristine, make it back to what it was before. You've substantially disrupted this habitat. Potentially, you can make the problem less bad. There can be some mitigation that is done, but it's not really fixing the disturbance that happened. As we mine things, we're looking at limited resources, things that formed over long scale geologic processes most of the time. And so, as we deplete those reserves, as we take out that ore, it becomes more expensive to get to things that are harder to access. If you have to go deeper into the ground, that's going to be more money, that's going to be more disturbance. And oftentimes, it's lower quality ore that now we're kind of relegated to. We have to access that instead. It's similar to what's called fishing down the food web, where if you take out all of the top level predators, you're kind of left with like the mackerel or the like anchovies and small stuff. Once you've gotten all of the tuna and salmon out of the water, you have to go smaller and smaller and smaller and get things that are less and less desirable for your food. It's similar with the ores in mining. Once you get the good stuff, you're left with kind of the less than stellar options. This is an infographic of what kind of reserves we have left, how much time we have left. Um, the thick bar is if we continue to grow operations, if we continue mining and speeding up the process of mining like we have been because more people need more things. The thicker bar is what that looks like if we continue growing mining operations at the same rate that we have been. The thinner bar that extends longer is if we did not ramp up production in these mining operations, how much would we have left? So you can see that a lot of our energy resources don't have that much left, which is why it's so important that we do a lot of research and try to establish renewable energy production methods because our fossil fuel reserves are not all that substantial. We also have limited materials in other capacities, not just in energy. So those other things down there are things that we either need for renewable energy for building things like solar panels or for other industrial processes. Like gold is used in a lot of electronics. So finding ways to recycle the materials that we have, finding ways to access things that we haven't been able to is going to be a big area of development. This map is the last slide on here, and this is the distribution of those reserves. The longer the bar, the higher the percentage of the remaining reserves that you would find there. So in the Middle East, that is where the majority of the oil reserves are found. We don't have a whole lot of oil in North America. We do have some natural gas reserves that are not shown on here that we've accessed with fracking, which we'll talk about in more detail later with the energy production part of Unit 6. But a lot of the oil reserves are in the Middle East, which is why it's such an area of global conflict. Same thing with Russia and other Soviet republics. They have a lot of coal reserves and gas reserves. The metals primarily are found in South and Central America. The renewable materials, a lot of them are found in Southeast Asia, the things that we would need for renewable energy. So this is why global cooperation and global relationships are so important when we're trying to figure out solutions to things like climate crises. All right, so that should be most of the information on the mining handout that I've provided for you. You will have to supplement some of the information like acid mine drainage. I'd like you to research that and figure out that process, as well as some of the real world examples of mining operations. So do some research, finish off the handout that I provided for you, and I will see you on Block Day.